Hello students, in this video we will study Laplace and Poisson's equation. We know from the Maxwell equation del dot D is equal to rho V and D is equal to epsilon into E. So we are putting here D is equal to epsilon into E. Epsilon is constant, so del dot E is equal to rho V by epsilon we can write. We know one more result, electrical intensity is negative gradient of V. So we will put this value here. So del dot minus of del V, it is equal to rho V by epsilon. So minus, this minus we can take on this side and it is del dot del V. So del dot del V is a del dot del, it means V is potential and it is scalar. So when first we are taking gradient, so gradient of V will be vector and divergence of gradient of V, it is again a scalar quantity. So gradient and after the divergence, this is called as Laplacian operator. This is called as del square operator. So this equation turns as del square V is equal to minus of rho V by epsilon and it is called as Poisson's equation. So the Laplace equation is the special case of Poisson's equation. Here rho V is the volume charge density. If there is no volume charges present in the space, then if rho V is equal to 0, it means no volume charge present. Then the equation turns as del square V is equal to 0. It is called as Laplace equation. So we can say that Laplace equation is a special case of Poisson equation when rho V is equal to 0. Okay, we should know the generalized expression of Laplacian operator. So Laplacian operator is calculated for a scalar quantity. Let A is scalar quantity, so del square A. The generalized expression is 1 upon h1 h2 h3 del over del u. h2 h3 by h1 del A over del u plus del over del v, h1 h3 by h2 del A over del v plus del over del w, h1 h2 by h3 del A over del w. That table h1 h2 h3 we have already seen. For the Cartesian coordinate system, h1 h2 h3 are 1 1 1 and u is equal to x, v is equal to y and w is equal to z. h1 is 1, h2 is 1, h3 is 1 for the Cartesian coordinate system. When we put all the values, then we get our answer is it is del to A over del x2 plus del to A over del y2 plus del to A over del z2. So this is the answer in the Cartesian coordinate system. In the cylindrical coordinate system, h1 is 1, h1 is 1, h2 is rho and h3 is 1. So 1 into rho into 1. So it is 1 upon rho del over del rho, rho del A over del rho plus del over del phi, 1 upon rho del A over del phi plus del over del z, rho del A over del z. You have to just put the values in the generalized expression and we will get the desired answer. In the spherical coordinate system, so del square A is equal to 1 upon r square sine theta. We should know the value of h1 is 1 here, h2 is r and h3 is r sine theta. So when we product this all, so we will get r square sine theta. So it is 1 upon r square sine theta del over del r. It is r square sine theta del A over del r plus del over del theta sine theta del A over del theta plus del over del phi, 1 upon sine theta del A over del phi. So these are the formulas of the Laplacian operator in the three coordinate system: Cartesian, cylindrical and spherical. Thank you for watching the video.